Hello students, welcome back to science class. Students, in the previous lectures of 10th class, we were discussing the chapter electricity. In that we discussed about the electric current, electric potential, potential difference and Ohm's law. In Ohm's law, we discussed that the electric current is directly proportional to the potential difference, but it is inversely proportional to the resistance. Now in the series of that lectures, today we are going to discuss one another topic, that is the factors on which resistance of a conductor depend. Now students, I would like to remember you what is resistance. As we discussed earlier, resistance, what is resistance? The property of a conductor due to which it opposes the flow of current. It resists the flow of current, it stops the flow of current, through it is called resistance. That property of the conductor due to which it opposes the flow of current. Right students, it is known as the resistance, and resistance was equal to potential difference upon current. If the resistance is more, the electric current will be less because they are inversely proportional and resistance is to stop the flow of charges. Now students, we will discuss about the factors on which the resistance of a conductor depend. The resistance of a conductor depends upon many factors like length, thickness and the nature of the material. Right student? It depends upon the length, thickness, nature of the material and also on the temperature. Now we will see step by step about these factors. Now first factor is the length. Resistance is directly proportional to the length of the material. Suppose students, we have this wire. It is suppose of 1 meter and another wire which is of 2 meter. Now the resistance in the shorter length, if the length of the wire is short, then resistance will also be less. If we increase the length of the wire or length of the material, the resistance will be more. Why is it so? Because students, resistance is due to the collision of the electrons with other electrons or atoms or ions. Here collision is going on. Right student? Resistance is due to the collision of the electrons with other atoms or the ions. If the length of the wire is more, the collision of the electrons with other electrons, atoms or ions will also be more. If the collision is more, the resistance will also be more. I repeat, resistance is due to the collision of the electrons with other atoms, other electrons or other ions. If the length of the wire is short, the collision will be short, so resistance will also be less. If the length of the wire, we increase the length of the wire, the collision is more and the resistance is also more. So the resistance is directly proportional to the length of the wire. If the resistance is more, about the length of the wire is more and the resistance will be more. If the length of the wire is short, the resistance will also be short. Now the second factor is thickness or area of the cross section. Now students, what is thickness or what is the area of the cross section? Suppose I have this marker. Here this portion will be its thickness and the area of the cross section. Now resistance is inversely proportional to the area of the cross section. If the area of the cross section is less, the wire is less thick, the resistance will be more. If the wire is thick more, it is more thick, then resistance will be less. It is opposite. We will see. Suppose here we have one wire of this thickness and we have one wire of this thickness. Here if the thickness is less, the resistance is more. If the area of cross section is more, resistance is less. Why it is less? Because suppose we take the example of a road. If the road is small, many vehicles have to go, but they will not able to go from a single road. Only less vehicles will be able to go, but if the road is very wide, many vehicles can move. Vehicle means many free electrons are they are easy to move. If the resistance is less, the free electrons moving are very less, and if the thickness is more, many free electrons can easily flow, and electricity is the flow of charges. Right, student? If the charges are flowing frequently and their number is more, then their resistivity is less. I think you must be able to understand. I repeat, if the thickness of the wire is less, the movement of the free electrons will be less, and in the thickness is more, the movement of the free electrons will be more, and opposite is case of the resistivity, because the resistivity is opposite to the electric current. Electric current is the flow of charges. If more charges are free to move, free electrons are moving here, so the flow of charge is more, the resistivity will be less. Here few free electrons are able to move because thickness is less, so resistivity will be more. So from this we have derived a formula that resistivity is directly proportional to length, but inversely proportional to area of cross section. We remove this proportionality sign with a constant rho. Rho is a constant of proportionality and is called electrical resistivity of a material of a conductor. This we called as rho. And SI unit of rho is because unit of this resistivity, SI unit of resistivity is ohm meter. Right, students? Now we see, we talked about the third factor, nature of the material. Now metals and alloys have very low resistance in range of 10 raised to power minus 8 ohm meter to 10 raised to power minus 6 ohm meter. They are very good conductors of electricity. Metals and alloys have very low resistivity, so they are very good conductor of electricity. Insulators like rubber and glass have resistivity of 10 raised to power 12 ohm meter to 10 raised to power 17 ohm meter. It means rubber and glass are insulators. They have lot of resistivity, and the metals and alloys are very good conductors of electricity because they have very less resistivity. Students, you must keep in mind one thing, that resistivity is to resist or to stop the flow of charges, so it is inversely proportional to the current. If we increase the resistivity, the current will be low. So that's why we have discussed the factors on which the resistance of a conductor depend. It depends upon the length. If the length is more, resistance is more. If the length is less, resistance is less. And it is inversely proportional to the area of the cross section, which is more, then resistance is less. If the area of cross section is less, resistance will be more. And this resistivity has SI unit ohm meter, and the constant of proportionality here is known as the rho. Metals and alloys are very good conductors of electricity, so this is the reason they have very less resistivity. Insulators are very much resistant, and they are rubber, glass examples. So student, this is all about the factors on which the resistance of a conductor depends. That's all for today's lecture. In the next lecture, we will discuss about the numericals based on all these topics. Till then, take care. Have a nice day. Thank you.